video. So today we'll be going through a Leetcode problem, which is best time to buy and sell stock number 3. So here is the problem. So you're given an array of prices, where prices I is the price of a given stock on the ith day. You are allowed to make a maximum of 2 transactions, and you should identify the maximum profit that you can achieve after these 2 transactions have been made. So here is the input. The input is an array of prices over the n days. Prices I is guaranteed to be at least 0. We can make a maximum of 2 buy-sell operations where you buy a stock on one day and sell a stock on another day, and you return the sum of the total profit from these 2 operations. You can note that you can make a maximum of 2 buy-sells, and the first buy-sell must be completed before the second buy-sell has been initiated. This means that we cannot have the following solution, where we buy a day 3 and sell a day 6, and also buy a day 3 and sell a day 5. This is not allowed, as the second buy-sell starts before the first buy-sell has been completed. Note that it is also possible for only one transaction to be required for maximal profit. In this example below, we can buy on day 1 and sell on day 8 for a maximum profit of 7. As such, we may not need to use 2 buy-sells entirely. Also, the 2 windows of the buy-sell operations must not overlap, but you can sell a previously bought stock on day I and buy another stock on day I as well. As we can see in this example, we sell a stock when its price is 31. After that is being sold, we buy another one at when its price is 31 as well. The above 2 buy-sell operations are valid as they follow the above rule. Thus, the candidates for the maximum profit from 2 buy-sells would be the sum of profits from 2 non-overlapping sub-arrays. In the example on top, the total profit will be 31 minus 2 added on to 5 minus 31. In the example below, the total profit will be 9 minus 4 added on to 5 minus 31. So, assuming that we can find the maximum profit possible within a subset of days, leaving gaps between your trading windows, as in A, may not be optimal. B's total profit will always be more maximal than A's. As you can see in A, we have 2 trading windows, one from day 1 to day 4 and one from day 6 to day 8. As you can see here, day 5 has been left out of both trading windows. In example B, we have 2 trading windows too. The first from day 1 to day 4, and second one from day 4 to day 8. As we can see, example A will be less optimal as the 5th day has not been considered in both trading windows. Thus, we can come to this insight which will help us formulate our approach to solving this problem. The maximum profit from 2 buy-sell operations can be found by finding the I, wherein the maximum profit made from any buy-sell within the first 5 days added on to the maximum profit made from any buy-sell made from the ith day till the end is maximal. So essentially what this means is that we need to find an I, which is between 0 and n minus 1 of the array, such that the maximum profit between from 0 to I added on to the maximum profit from I to the end is maximal. So we can iterate through all the i's and identify which is the best I and which gives us the best profit. So now we have our sub-problem, which is that we need to devise a method to find the maximum profit from any buy-sell made within the first I days and the maximum profit from any buy-sell made from the ith day till the end of the array. So thus, we'll end up with 2 arrays. The first array being maximum till I, which contains maximum profits from any trade between 0 and the ith index, and the maximum from I, which would show you the maximum profits possible from I to n minus 1 in the array. So how will we populate the maximum till I array? So initially, the maximum profit, we set it to be prices 1 minus prices 0, as that is the first profit we can make from the array. We move from left to right in this scenario. We also create a variable called minimum from left and set it to be prices 0. As we can note here, we set the first minimum profit is 7 minus 4, which is 3, and in the mx maximum till I array, we set the first index to be 3, and minimum from left is 4. Then for the next element, which is mx till I and at the index 2, we note that prices 1 can now be bought. So we now need to adjust the minimum price from the left to be the minimum of prices 1 and minimum from left. So as we can see in this example below, the maximum profit is going to be maximum of 3, which is mx till I at index 1, and prices 2, which is 2 minus the minimum from the left, which is 4. So now we can set this maximum profit, which still remains to be 3. But now we notice that the new minimum from left is going to be 2, as it is smaller than 4. So in this example, we note that mx till I at index 2 is equal to the maximum of mx till I at index 1 and prices 2 minus the minimum from left. We keep adjusting the minimum price as we go from the left to the right. So generally, maximum till I for the ith index is the maximum of maximum till I for the I minus 1 index and prices I minus the minimum value from the left. So we also need to generate the maximum from I array, which will show you the maximum profit possible from index I till the end of the array. So for this scenario, we will have to start from the end of the array and iterate backwards. So initially, maximum profit is going to be prices minus 1, which is 5, minus prices minus 2, which is 2. So maximum profit is going to be 5 minus 2, which is going to be 3. And we set the maximum from the right value to be prices minus 1, which is 5. So now we can set the mx from I array at the second last position to be 3, which is a profit. Yeah, and the maximum from right is still 5, as 2 is still smaller than 5. Then for mx till I at index minus 3, note that we can now sell prices minus 2, which is 2. So we need to adjust the maximum price from the right to maximum prices minus 2 and mx from right. But in this example, as explained earlier, 2 is smaller than 5, so the maximum from right still remains to be 5. And in this example below, the maximum profit for the negative for the minus third index is going to be the maximum of the previous profit, which was 3 and 5 minus 31. And now we notice that 31 is larger than the previous maximum from right of 5, so we set the maximum from right to be 31 instead. So as similar to the previous case, we keep updating the maximum from right as we move from the right to the left of the array. So generally, this is a case of how you formulate the maximum from I array. So the maximum from I at the negative ith index is the maximum from I at the negative I plus 1 index, and the maximum from right minus the prices and at the negative ith index. So here is the code that was used to solve this problem in Python. So this is the construction of the maximum till ith array. As you can see, it's a singular for loop. And here is the code for the maximum from ith array. And note that we create a variable res which contains the maximal sum from index 0 to the end of the array. So this is an example where we shared earlier where you only need one transaction, right? So this will ensure that that is captured. And also to prevent going through looping another time, we create a maximum check for rest for result uh, at the end of each iteration of the loop. And at the end we return res, which will now be maximum. So as we can see through the code and the explanations, the time complexity is big O of n, and the space complexity is big O of n as well. And yep, that will be the solution for this problem. Thank you and have a great day ahead.